Welcome to the Tech Playbook, where we dive inside the stack. This is where we explore how products are built, how teams work, and the systems and decisions that power modern technology. Today, we're breaking down a massive topic into something super simple, visual, and just really easy to understand. We're looking at the foundational components of a modern AI ecosystem. Now, you might be wondering, why does this matter? Well, because whether you realize it or not, these 6 layers are rapidly changing how we work, how we create, and basically how we live. Understanding the stack means understanding the future.
So in this explainer, we're going to explore the 6 main categories of modern AI technology, layer by layer. We've got generative AI, large language models, prompt engineering, RAG, AI agents, and finally, agentic AI. Let's get right to it.
Okay, let's dive into this, starting right at the bottom with layer number 1, generative AI, which is our base. Think of generative AI as the foundational bedrock of our entire stack. Without this core shift in technology, absolutely nothing else we talk about today would even be possible. You see, for years, traditional AI was kind of like a really fast, highly efficient sorting clerk. It would look at incoming data and just classify it, like it could tell a dog from a cat in a photo, or separate a spam email from a real message in your inbox. And hey, that was incredibly useful, but its capabilities pretty much stopped right there. Generative AI fundamentally changes the game. It actually captures the underlying distribution of the data. It learns the deep, complex mathematical correlations behind how things are constructed, and then uses those learned patterns to synthesize entirely new, realistic things. It doesn't just sort the mail anymore. It writes a brand new original letter. We're talking creating text, writing software code, and generating images completely from scratch. It is literally the creative engine that sparked this whole revolution. Building right on top of that generative foundation, we move up to layer 2, large language models, the engine. So if generative AI is the bedrock, the large language model, or LLM, is the high-powered reasoning engine sitting right on top of it. An LLM is built on what's called a transformer architecture. To really grasp why this is so revolutionary, you kind of have to look at the past. Before transformers, AI read text word by word, completely sequentially. It was like reading a book through a tiny keyhole. It was slow, and it often lost the context of what it was reading. But transformers use this clever mechanism called self-attention. Imagine reading a long, complicated paragraph and instantly, simultaneously, knowing how every single word relates to every other word in that text. That's what self-attention does. It processes entire sequences at once. And ultimately, its main job is amazingly simple but incredibly powerful, predicting the next word or token in a sequence. By doing this across billions of parameters, which are basically the tiny adjustable dials the model uses to tune its understanding, it acts as the primary brain of the operation, generating language with incredible accuracy and nuance. But here's the catch. While this reasoning engine has vast, generalized knowledge from reading essentially the entire public internet, it's completely disconnected from your private internal world. Imagine a highly intelligent person standing next to a heavily bolted, locked file cabinet that holds all your company's proprietary information. The LLM is that person, and it has absolutely zero awareness of what's inside your cabinet. An isolated engine just can't solve domain-specific enterprise problems on its own. Its knowledge is essentially frozen in time from the exact moment it finished its training. So it doesn't know about yesterday's news, and it certainly doesn't know about your internal sales data. It needs a way to be directed, and crucially, it needs a way to access fresh, private information.
And that brings us to layer 3, prompt engineering, or as we like to call it, the steering.
So we've got our massive reasoning engine, right? But an engine isn't much use if you can't point it in the right direction. We need a steering wheel. We need a way to direct this LLM without opening up the hood and rewriting its underlying code. Prompts are no longer just simple text strings you type into a chat box. They've evolved into the source code that dictates the behavior of your AI. Advanced prompting techniques act as this complex scaffolding. For instance, we start with few-shot prompting, which is where you give the model a few highly specific, high-quality examples to follow before asking it to do a task. Then there's chain of thought, which forces the AI to basically think out loud and show its step-by-step reasoning before giving a final answer. This one simple trick drastically improves the model's logic and reduces errors. If we want to get even more advanced, tree of thoughts lets the model explore multiple different branching ideas at once to find the best path. And finally, react combines reasoning with taking external actions. Treating prompts as actual code significantly boosts our engine's performance without changing the engine itself. Moving right along, let's look at layer 4, RAG, the memory. We have the engine and the steering wheel. But remember that locked file cabinet we talked about earlier? We need to give our AI system a highly specific, up-to-date memory. And we do this through RAG, which stands for Retrieval Augmented Generation. RAG is essentially like giving our LLM a strictly monitored open book test. The pipeline works in 3 very clear steps. First, when you ask a question, the system searches, or retrieves, relevant real-time data from a secure digital library, often called a vector database. This is just a super efficient way to store information so an AI can find exactly what it needs, based on meaning, not just exact keywords. Second, the system augments your original prompt by attaching this freshly retrieved context directly to it. Finally, it sends that newly combined package to the LLM to generate a factual grounded response. This whole process is how we combat AI hallucinations. We're forcing the model to base its answers strictly on your actual current data, rather than just guessing.
All right, before we move to the final layers, it's time for a quick pop quiz to see who's been paying attention. What does RAG stand for, and what specific problem does it solve for an LLM? I want you to write your answer to the question below in the comments. Seriously, pause the explainer, drop your answer down there, and let's see if you nailed it.
Awesome. Now transitioning up to the 5th layer, AI agents, the hands. So far, our AI stack can think with its engine, it can be steered with prompts, and it remembers specific facts with reg. But it's still trapped behind a screen, just generating text. Now it finally gains the ability to interact with the real world. An AI agent operates in this continuous dynamic loop: perception, reasoning, and action. It acts way less like a calculator, and honestly much more like a diligent employee. It uses the LLM as its core brain to formulate a solid plan, and then it actually calls on external tools to execute real tasks. It does this using digital bridges called APIs, which just allow different software programs to securely talk to each other. Thanks to these APIs, the agent can actively check your live databases, search the web for current data, or even automatically schedule meetings on your calendar, all within the explicit boundaries you set for it. This quote really illustrates a massive evolutionary leap in technology. Agents are LLMs given access to external tools. Instead of just answering a question, an agent can formulate a plan, search the web, and execute code. We have completely moved away from passive text generation into active, real-world execution. However, it's important to keep in mind that a standard AI agent is still somewhat limited. Usually, an agent just executes the one specific, narrow task you assign to it, and then it waits for human instruction before doing anything else. Which brings us to our final layer, Layer 6, Agentic AI, the manager. So what happens when you need to coordinate multiple AI employees to achieve a massive, overarching business goal? Let's break down the critical difference between our last 2 layers. Standard AI agents are task executors. They're reactive. They sit around waiting for your instruction, and they operate strictly inside narrow, predefined boundaries. Agentic systems, on the other hand, are goal achievers. They are intensely proactive. They don't just do a single task. They orchestrate multiple different agents and software systems completely autonomously. If a standard agent is a frontline worker waiting for a support ticket to come in, Agentic AI is the high-level manager figuring out the entire underlying strategy to solve the customer's broader problem without you having to hold its hand every step of the way. Our multi-layered stack ultimately culminates right here in Agentic AI. When you give an agentic system a high-level, complex objective, it has the autonomy to break that massive goal down into smaller, actionable steps entirely by itself. It dynamically chooses which tools or which specific specialized AI agents to deploy for each of those individual steps. It continuously evaluates its own progress through that perception, reasoning, action loop. And crucially, if it hits a roadblock or gets an error, it adapts to the new information and tries a totally new strategy on the fly. This level of autonomy completely transforms the way we deploy intelligent systems in production. We are moving away from isolated parlor tricks and simple chatbots toward robust, autonomous problem-solving engines that can literally run entire segments of a business. From the generative base all the way up to agentic orchestration, that is the modern AI ecosystem stacked up and simplified. But honestly, it leaves us with one massive lingering question to think about. As these agentic managers become fully autonomous and capable of running complex operations entirely on their own, what role will humans play in the companies of tomorrow? Thanks for tuning into this episode brought to you by the Tech Playbook Inside the Stack. Like, comment, and subscribe for clear, practical tech education. This is the Tech Playbook, and you're inside the stack.